In this problem, once again, we're going to be working with the ideal gas law, but we're also going to be working with stoichiometry. I know I said a very bad word, but we're going to be combining stoichiometry with the ideal gas law. So the question reads as such. When 35.6 liters of ammonia and 40.5 liters of oxygen burn at STP, nitrogen monoxide and water are going to form. After the products return to STP, how many grams of nitrogen monoxide are present? And so we're going to have ammonia reacting with oxygen to produce nitrogen monoxide and water. Now this is going to be an unbalanced equation. And if we want to balance it, we're going to have to put a 4 here. We'll put a 5 there. We'll put a 4 there. And we'll put a 6 here. And so that gives us 4 nitrogens, 4 nitrogens. We have 12 hydrogens. We have 12 hydrogens. We have 10 oxygens. We have 4 and 6. That gives us 10 oxygens. So now it's balanced. And we're going to have to determine the number of moles for each ammonia as well as for oxygen using the ideal gas law. So N for the number of moles of ammonia is going to be equal to PV all upon RT. And if we plug in that information that we have here, it is 1 atmosphere times the volume, which is 35.6 liters, divided by R, which is 0.08206 liter atmosphere mole Kelvin, times the temperature, which is standard temperature, that's 298.15 Kelvin. And so we do this arithmetic, and what we end up with is 1.455 moles of ammonia. We can do the exact same thing when it comes to the moles of oxygen. We do the exact same thing when it comes to the moles of oxygen. That's going to be 1 atmosphere times now the volume, which is 40.5 liters, divided by R, which is 0.08206 liter atmosphere mole Kelvin, times the temperature, which is 298.15 Kelvin. I didn't go through the units carefully, but the kelvins cancel with the kelvins, the liters cancel with the liters, and the atmospheres cancel with the atmospheres. So we have an inverse. We have 1 over an inverse, which is going to give us the units of moles. And so this is going to give us 1.655 moles of oxygen. Now we got to do a little bit of stoichiometry. And we want to determine how much nitrogen monoxide is produced from the 2 quantities of gas that we have. So if we have 1.455 moles of ammonia, we want to determine how much nitrogen monoxide is going to be produced from that. And we know that there are 4 moles of nitrogen monoxide for every 4 moles of NH3. The moles of NH3 are going to cancel, and this is going to give us 1.455 moles of nitrogen monoxide. We can do the exact same thing with oxygen. So in that case, it's 1.655 moles of oxygen times, now we have to look at the mole ratio. And so this is 4 moles of NO to 5 moles of oxygen. And when we do that arithmetic, we end up getting 1.325 4 moles of NO. So what this tells us is, it tells us that this is the limiting reagent, that it's the oxygen that's going to determine the amount of nitrogen monoxide, because it produces the least amount of nitrogen monoxide. Therefore, the oxygen is going to run out first. The oxygen is going to run out first. So we know that there can only be produced, the only amount of nitrogen monoxide that can be produced is 1.324 moles, because we will run out of the oxygen before we run out the ammonia. We produce more nitrogen monoxide with the ammonia, but we're going to be consuming the oxygen much, much greater. Therefore, it's the oxygen that's going to limit the amount of nitrogen monoxide that we get produced. Now we want to come up with the grams of nitrogen monoxide, and we're going to be using this number because that's as much as we can possibly produce. So we start with that, and we're going to convert that into grams. So we have 1.324 moles of nitrogen monoxide, and we convert that into the molar mass. And so 1 mole of NO is equal to 30 grams of NO from the periodic table. We do that arithmetic, and we end up getting 39.72 grams of nitrogen monoxide is the mass of nitrogen monoxide that we can produce. All right? Once again, if you have any questions on gas law, stoichiometry, please ask.